Welcome to Chemistry at Hononegah High School. Today we're going to look at ions, polyatomic ions. Maybe you've got a teacher and the teacher's saying, you need to know these ions for what we're going to be doing with writing formulas and balancing equations and so forth. Or maybe, like with my students, you've got a test coming up, and this is a full test, and all it really is understanding and being able to differentiate between different ions. Well, I've got 27 ions that I want my students to know. So how can you break those down to try and make that test significantly easier? Well, memorizing 27 things, that's not always easy. If you're great at memorization, then more power to you. But if you're like me and most other people, it'd be easier if we could know a few things and apply a few things and figure out all 27. So what we're going to look at is how can you break down the 27 ions that I want you to know for the test. Now first, and this is going to require having a periodic table, so get a periodic table handy. Several times through this, you're going to need your periodic table. So if you don't have one, pause the movie now, go get one. It will make a huge difference. Okay, first off, some of the ions that you need to know are what we call monatomic, single atom ions. Now, all of our monatomic ions are single atom negative ions. So they're what we call anions. So that's one thing that will help with this is if you know it's a monatomic, you know it's going to be negative for all the ones that we're looking at. So how do you deal with a monatomic anion? Well, what we end up doing with them is we add the suffix "ide." So sulfur becomes sulfide, oxygen becomes oxide, fluorine becomes fluoride, chlorine becomes chloride, and so forth. So if you see an "ide" ending, it's a pretty good guess that what we're dealing with is a negative monatomic ion. There are two exceptions to that, which we'll see at the end. So what we do if we've got a monatomic anion is we take the old name and we change its suffix to "ide." So when you look at these, which are all in the test, nitride, oxide, sulfide, fluoride, chloride, bromide, iodide, hydride, all of these are negative. So notice they're all anions. And notice what we've really done is taken the old element name and changed it to IDE. So when you see that name, "ide," first thing you should think of is it one of the monatomic negatives? Now, how do we get the charges that we see here? Well, that's where your periodic table really comes in handy. Remember, one of the discussions we've had deals with the fact that our noble gases are stable and they have the right number of electrons. Well, these are all nonmetals in our list here, and we've also talked about how nonmetals are things that gain electrons to become stable. Well, if you look at where it's at in the periodic table and how far it is away from its nearest noble gas, that tells you how many electrons it needs to gain. Nitrogen is 3 away from neon. It's going to gain 3. Gain 3 negatives, that's N3 minus. Oxygen is 2 away from neon, so O2 minus. Fluorine is 1 away, so F minus. And notice all of our halogens, fluorine, chlorine, bromine, iodine, all of them are a -1. That's because they're all 1 away from the nearest noble gas. So look at and use your periodic table. And these are all very, very, very easy. Now the last one's a little bit trickier, hydrogen, because it's way on the far left of the table. But if you notice, in that first period, it's really just 1 away from helium. So if it could gain 1 electron, it would become not hydrogen, but hydride, and it would have a stable number of electrons just like helium does. So all of these in the test should be dead easy. So that takes care of 1, 2, 3, 4, 5, 6, 7, 8 of them. 8 over 27, piece of cake on those. That's almost a quarter of the test. Now, I did mention at the beginning that there are two that have "ide" that aren't monatomic. So these two you really do have to know. So the only two "ide" ions that we deal with for the test that are not monatomic would be oxide. I'm sorry, I'm looking at the O and saying it. Hydroxide and cyanide. Both of these do end in "ide, but if you look at their formulas, they're more than a single atom. Now the first one, hydroxide, look at the name. Hydroxide, hydrogen, oxygen. So that's a dead giveaway as to what we have. Now, one of the things we're talking about in a second is hydrogen is often the H plus ion. Now, that's not the hydride we're talking about here where you gain electron. But another thing that hydrogen can do, just like the other metals that it's in the same column as, would be to lose one and become stable. So the hydrogen ion, not the hydride anion, but the hydrogen ion is H plus. Well, if O is 2 minus from over here, and we're putting it with an H plus that we're going to talk about in a second, that would be OH, and overall we would have a -1. Exactly where that comes from. So if you remember the H plus thing we talk about next, put it with oxide, you got your hydroxide. And that just leaves cyanide. It's got a carbon, it's got a nitrogen, it's a -1, just like hydroxide, our other non-monatomic thing. So hydroxide, cyanide, plus our other 8, now we're up to 10. Now, next thing I want to talk about that hydrogen ion thing. Hydrogen ions, not the hydride anion, but hydrogen ions are an H+. So if we have a name that's got hydrogen in it, all we're really doing is adding an H+ to whatever else it's with. So sulfide, well, remember that's S2-, based on where it's at in the periodic table. If we put an H+ with it, what we're going to end up with is HS, and its overall charge is going to be a minus. That's where hydrogen sulfide comes from. Phosphate, which we're going to end up looking at later. How can I remember it's PO4 and it is a 3-? How can I remember that? Well, we'll talk about that later. But if I have dihydrogen phosphate, di means 2. So if I stick 2 H pluses on here, well, I'm going to have 2 of the hydrogens then. And I'm still going to have my PO4, but my overall charge, +1, +1, -3. What I'm left with is -1. That's where that comes from. So if you look at a name where you've got hydrogen in it, so that means add that many H pluses, and whatever you get is whatever you get. So that takes care of 2 more from our 27. So anything with hydrogen in its name, that's how you handle it. Now, next one, really important set here that we're going to use in a couple of different ways, dealing with families. Now, before we get into that, you need to understand that there are many polyatomic ions that are oxyanions. In other words, it's an anion and they've got oxygen in them. So we have some metal or nonmetal, and with it we're sticking a bunch of hydrogens, and we're making a polyatomic ion. So if you see 8s or ites, that's our dead giveaway that it's an oxyanion. It's a compound with oxygen in it. 100% of the time, when you see 8 and you see ite in the name, you know you're going to have oxygen in there. So if a nonmetal forms with 2 possible anions with oxygen, one is going to be larger, have more oxygens than the other one. The larger number of oxygen we always call the 8, and the smaller number of oxygen one we always call ite. So we've got 2 examples of that that you need to know for the test: sulfate, sulfite, and nitrate, nitrite. If you look, all you really need to recognize is if you know one of them, you know the other. So if I know sulfate is SO4, ite means 1 less oxygen. 4 becomes 3. So same charge, but with 1 less oxygen. Same thing here with nitrate to nitrite. If I know nitrate is NO3, then I know nitrite is going to be NO2. So remember, ite always means 1 less oxygen than the 8. And we're going to look at in a second how you can remember that, those 3s and 4s and 2s that we see as subscripts here. There's an easy way or a way to help remember that. So those would be what we call families. Now, some families only have 2 ions in them, so they just have an 8 and ite, and the 8's 1 more oxygen. But there are some elements that make a family of 4 nonmetals with oxygens in it. Well, we need a way to basically do the same thing to differentiate between how many oxygens we've got. Well, we use then per and hypo along with what we did before. So if we look at this family, we have ClO-, ClO2-, ClO3-, and ClO4-. Notice they're all -1s. And the only real difference is they have a different number of oxygens. Well, notice in the middle here our 8-ite situation. Same as I just talked about a second ago. The ite has 1 less oxygen than the 8. So if I know chlorate is ClO3-, then I know chlorite has to be ClO2-. Now, the 1 more oxygen than the 8 and the 1 less oxygen than the ite, we use the per and the hypo along with the other name. So when we have ClO4-, instead of chlorate, it's perchlorate. And that per plus 8 means 1 more O than the 8. And how do we show 1 less oxygen than the ite? Well, we would use hypoite. So hypoite means another oxygen is being taken away. So literally it would be 2 less O's than the 8. So I bolded the 8 here because if I remember that one and I know this relationship, I know all 4. Ite is always 1 less than the 8, hypoite is going to be 2 less, and per 8 is going to be 1 more. So all I need to know is 1, and I get a whole bunch more out of that. And how do I know ClO3 is a 3? Well, we'll look at a way to remember that in a second here. because that gets into what we're dealing with here on the periodic table. Now, as a quick review of what I talked about earlier, since I didn't have a periodic table, remember we have these things right here and these things right here that we looked at knowing their formulas of, along with this one over here. Now, what was I saying about where it's at and how that tells you what its charge is going to be? All of these in this column are 1 away from the nearest noble gas. So that means they all form -1 ions. All of these in this would be 2 away. They all form -2. And this one is 3 away, so it's going to form a -3. And notice the hydrogen here, really, I know there's a huge gap, but it's only 1 away. So when we're going from H to HE, that's just 1 away. This is going to form a -1 as well. So that was what we looked at the beginning of the notes. So that was just a quick reminder of something from earlier, now that we're actually looking at a periodic table. Now let me wipe the slate clean here so we can look at elbow. How do we remember those tricky ones where we need to know sulfate is SO4 and we need to know nitrate is NO3 and permanganate is MnO4 and so on? How to remember those types of things? Well, there's a way to do it if you know where the elbow is on the periodic table. So what is elbow? Well, there it is. So it looks like the number 7 there. Those are our elbow elements. Now, anything in the elbow, when you put it together with oxygen to make an oxyanion, the 8 version of the ion will always have 3 oxygens, and therefore the 8 version would have 1 less, which would be 2 oxygens. So anytime I try and put together anything from this elbow, because it looks like my arm bent here, and I'm making an oxyanion, I know the 8s are always going to be a 3 minus, and the 8s are always going to be a 2 minus. So carbonate has to be CO3, 2 minus. Nitrate would be NO3. Chlorate would be ClO3. Notice they each have 3 oxygens, which is exactly what this is all about. So I now know that the 8s of all of these, because they're in the elbow, always have to have 3 oxygens. Now, if you're outside of the elbow, then a different set of numbers apply. So remember, in elbow, 8 is always 3. And remember, 8's always 1 less anyway, so all I really have to remember is in elbow, the 8 version will always have 3 oxygens. Now, one thing I did want to point out related to this before we get to outside the elbow. Carbonate was CO3, 2 minus, and nitrate then was NO3 minus. How do I keep those apart and maybe help remember what my charge is? Well, notice carbon was 1 further away, so it had the -2, and nitrogen had the -1. So if I remember nitrate is -1 and I look that carbon is 1 left, that might help remember that the carbonate is going to be a -2. And all of my halogens are 1 away from the nearest noble gas, and before that meant a -1. So notice it is also a -1. So that might be a way to help remember that carbonate was a -2, nitrate was a -1, and chlorate was a -1. Now, that would be things in the elbow. So if you're elbow, that's exactly how things work. Now, what happens if you're an oxyanion outside of elbow? Well, now 8 is 4. And we had 4 of them in our list. We had sulfate, phosphate, permanganate, and chromate. If you notice, each and every one of these has 4 O's, and they're all 8s. So when we had to go to like sulfite, remember that just means 1 less. So if you look at where things are at, in the elbow or out of the elbow has 3 oxygens in an 8. Outside of the elbow, 4 oxygens in an 8. Now, the other thing is about charge. And once again, notice this was a 3 and that was a 2. The one farther left had 1 more. This was a 2 and this was a 1 as far as the negative charge. Once again, the one farther left had 1 more. So maybe that can help you with the charges. And this is really a way to break down all the different ions in a way that might make it easier to do well on this test. So good luck preparing for the test. Don't forget the practice ion test, which is basically the same thing but harder. So it just has multiple choice, 5 choices instead of 4. So if you can ace that, there's no reason why you can't ace the overall ion test. Good luck preparing. Hope this helped.